Welcome back, everyone. Welcome back. I think we have everyone. We are entering the last phase of our two-day workshop, which is going to be focused on specifically scripting. We'll finish up with viewing the analyses. Scripting, how to import things like your custom atlas, doing a PPI analysis as well, and then we'll be reviewing some potential data sets for analyzing. We'll set up a template, and then I'll try to get the ball rolling. And after I leave, if we have some idea about what data set we want to analyze, I'll make a walkthrough for that, just to, try to apply it to a different scenario. Stretch our possibilities. I'm not going to show any more slides because, well, the ones I had, I think I can mostly demonstrate them through the CONN GUI. And also, there's some weird interaction with the PowerPoint and CONN Toolbox, and it's causing things to freeze. So from now on, no more slides. Okay. From where we left off, we had the CONN Toolbox open, and we were on the second level analysis. So if we have Seed-to-Voxel highlighted, if you've been following along so far, we now have second level covariates for group A, group B, if we want to take the difference, and also age _1, which is simply the age covariate. So if I select something like group A and group B together, you can select the difference between them through this drop-down menu here. And note that you won't see an updated result over here. To see the actual results, we need to click on Results Explorer. So at this time, click on that. Should only take a few moments. Bless you. Now, this isn't an error or anything. If we're looking at something like the first three subjects compared to the last three subjects, obviously, since they're so closely matched, we're not going to find a significant difference at the group level. What I'd like you to try is at this drop-down menu up at the top, if you click on Advanced Family-Wise Error Control Settings, here are those cluster defining thresholds that we mentioned yesterday. Let me try changing this to something a little bit more lenient. Yeah, something like this, just to give you a sense of how these results actually look. So that voxel threshold, I changed it to 0.1. So now we're looking at each individual voxel passing a 0.1 threshold. You would never do this for an actual inferential test. I just want to show you how the results actually look. The default, which was selected initially, was using this random field theory to generate those cluster simulations to find which clusters are actually significant. Oh, yeah, so this is actually converted to, these maps are all converted to z-scores, and then we're running a group level analysis. So for example, if I have, let's see here, yeah, right, and let's see, this is, I believe, based on the left frontal pole. So whatever seed region was selected in the second level results is what we're going to be viewing right here. So obviously, for this particular analysis, these clusters are too large to do any sort of, valid inference. But if you're doing a group comparison, that's how you would do it. Random field theory is going to give you an actual valid cluster correction. So, this is just demonstrating how the basic format works, and also that there is not a significant difference in any meaningful sense of the word between the two artificial groups we created. If we want to select, so I'm going to close out of that. Let's say this is like an F test for all subjects. I'm going to go to the other extreme. If you just highlight this, you click on Results Explorer. Let's click on Recompute, Overwrite Results. and you should see something like this. So again, this is based on whatever seed you select right here. This is going to generate a different second level result in the project directory. So if I did the same thing for, say, frontal pole left, then I would also click on Results Explorer to generate that as well. Okay. You can see here that there's no option to correct for the number of tests that you do, which is why it makes more sense to have some kind of restricted range of seeds that you're going to analyze. If I do this for each one individually, if this F-test all subjects analysis, I'm going to find some significant results, but for a group analysis, we need to be a little bit more stringent. So with this glass brain, I'm just going to show you a few of the features. There's a ton of buttons, a ton of options. We're not going to go through all of them. But as you click on different clusters, you'll see it highlighted in this table down here. So it gives you the size of the cluster in voxels. And these have been resampled to 2 by 2 by 2, I believe. What's the significance for the size of the cluster itself? It also gives you an alternative way called false discovery rate. I'm not going to go into it, but it's another way for correcting for multiple comparisons, as well as the peak voxel corrected for family-wise error. So that's Bonferroni correction across all the voxels in the brain. All right. If I want to view these results on a template, for example, you have this more inflated surface and a more convoluted cortical surface. Let's click on this surface display right here. And again, here's what I really like about the CONN Toolbox. So many options how to view it, and the plots look pretty nice. You can click and drag this, go around. Notice that obviously the highest correlation is in the right frontal pole, a little bit of bilateral activation. There's also small clusters around the rest of the brain. You could take a snapshot here, for example. You could view it on another cortical surface. The main advantage of using a more inflated surface is you get a better sense of how these Z statistics are hugging onto the folds of the brain, which can give you better spatial localization. One thing I do want to point out, this seems like a trivial point, but it's actually pretty important. All of these results are resampled onto a cortical surface. The analysis was not done on the cortical surface. Again, you don't need to follow along with this, so I'm taking a brief detour. Let's see here. If I did want to analyze everything on the surface, I would first have to do everything through FreeSurfer. In that case, let's see, if I were to do, again, I'm not encouraging you to do this. I don't want anything to go wrong. But let's see here. Do I have the option to do that? Click on Add. Yeah. So when we first did the analysis, we did everything in volumetric space. If you ran everything through FreeSurfer and all your data is now linked onto a surface, you can instead do a pre-processing pipeline for surface-based analyses. Okay, a lot of options here. In case you do want to follow that route, aside from creating the actual surfaces, everything else should be pretty similar after that. I encourage you to, from the book, there's a FreeSurfer module. And this will take you through how to reconstruct those surfaces. Up to you. Upside, you get to really see where these activations lie, these correlations lie. Downside, it takes a lot of memory and takes a long time to do. So I would only recommend that if you have access to some kind of computing cluster to speed that up. There's so many options, we can't get to all of them, unfortunately. Let's see here, what else? I'll leave most of this up to you. The last thing I want to show on this screen is the SPM display. So if you're more comfortable, say, looking at all this through SPM, the results manager, this looks familiar, looks pretty comfortable. You want to set all the thresholds here. You're free to do so. The connectivity result, obviously, is the group level analysis across all of them. And you can go through, apply masking, apply a certain threshold. Maybe I did my, cluster correction outside of SPM. I trust that more for whatever reason. I'm going to get something very similar, but you do it through the SPM interface if you're more comfortable with that. Okay, so makes sense so far. Something I am also going to direct your attention to. There's so many rabbit holes to go down, but because I mentioned using the correlation maps in an outside toolbox, I want to mention that as well. Where the actual maps are located. So within, let's say, I have everything in CONN demo backup. Feel free to follow along if you want to, but from the MATLAB terminal, but don't worry too much about it. You can just sit back and watch if you want. In this case, what did I call this one? It was CONN Arithmetic Project, or whatever you called your group level analysis project. Within this, there are a lot of directories. There's the results directory, and this becomes more and more populated as you do more analyses. So as we did the pre-processing, everything was in the pre-processing directory for that. That is what the CONN Toolbox is calling upon when it displays everything. Same thing for, let's say, first level results. Okay, we didn't do dynamic connectivity. We didn't do voxel to voxel, but we did do seed-based connectivity. So I'm going to focus on that one in particular. And you will see these beta maps. They're correlation maps converted to a normally distributed variable here. So we have a beta for each subject for each source. You'll need to look at how far should I go into this? Remember I said that the Alice has a certain number associated with each parcellation, each source, each seed. So source 001, for example, is the right frontal pole, right? If I scroll up here, this is seed number 1, seed number 2, 3, and so on. This is how you'd link these two things up. And you'll notice that I get to maximum number of sources, I go to subject 2, and so on. So if you wanted to use these are the actual maps you would feed into it. I'm just going to show in a viewer basically how they look. I'll use AFI in this case. So this is the converted connectivity map for subject 1, source 001. So obviously, it's highest over here. And you could take these, you could analyze them in whatever package you want. CONN is just useful because it can load them automatically. Okay, so just be aware everything that you're seeing in the CONN GUI can be accessed within the project folder for more advanced analyses. And lastly, let's see here, second level SPC 01. I'll table that for now. I'll send out more information about if you want to access an spm.mat file, which has all of these converted z-scores in a matrix. If you feel more comfortable with that, I can send out instructions about how to do that. We simply can't cover all the different options. But I'm hoping you get some idea of the organization and what you can do with it. Okay, last thing about viewing the results, if we go back to the CONN Toolbox, click on ROI-to-ROI, you will see a setup like this. You'll see a montage of the brains. You can increase the number of slices that are displayed by going up or down on this slider right here. But whatever we have, whatever node is outlined in gray is the current seed region. So we're looking at how it's connected to all the other seeds. And there's a threshold beneath all this where you can determine, okay, how strong does the connectivity need to be for it to be significant? For a group level analysis like this, an F-test really not too surprising. It has a lot of significant correlations. Clicking on any of these other nodes, for example, I think that's middle frontal gyrus. It'll show you what it actually is. you'll see a distribution of the connectivity values between that and your seed region. So go ahead, play around with this a little bit. Just select some different, take a few minutes here. Select some different ones, see how this entire web updates. Try some different thresholds, see how that either reveals or hides more connections, and also see how this is connected to the targets menu down here. So we'll come back in a couple minutes. Just get familiar, dip your toes in, try it out. And if you want to test a little bit what you've learned as an exercise, see if you can do the same thing for comparing group A to group B, where it's larger group A to group B, and some other contrasts. You can do one-sided, two-sided, display 3D. Okay, starting to make sense. Pretty easy to understand. I like this layout quite a bit. You may have seen me doing a few things up here. Something that can make a pretty nice figure if you found something that you want to focus on is display 3D. So it's just showing this montage in 3 dimensions in which the seed region, this creates the left pre-central gyrus, is in gray, and all the positive connections are in red. And the size of the connection is represented by the size of the sphere. You have billions and billions of options, so you can really knock yourself out here. Okay. Now, when we look at ROI to ROI, we have 2 options for how to look at the results. One is graph theory, and one is results explorer. We recently talked about graph theory, some different metrics we can use. So let's go ahead and click on that. My voice is starting to crack, and I apologize, but it's just that time of the day when it starts to fall apart. I'm dying. By default, it's going to give you a network of all the possible ROIs, right? The only threshold, and that's at the very top here, this is cost, right? So let me try to remember how this is structured exactly. If you wanted something like, say, correlation coefficient, you're only going to look at edges that pass a certain threshold. As you decrease this number, let's say press enter, just wait for it to update. Come on. Let's finish. Let me find a clearer threshold to demonstrate what I'm talking about. I believe, so as we say decreases to 0.05, it's showing, I believe, everything above that correlation coefficient. Yeah. So you may have noticed that the mesh gets a little denser as you increase it. So we have all the ROIs. Oh, it's still working. Yeah. We have all the ROIs, but you may only want to focus on a subset of the ROIs. Oh, I should also mention, given those a few of these things that we talked about, like, say, local efficiency. So if we have a particular seed selected, we're trying to determine whether a network between that and the other ROIs does in fact exist, local efficiency is going to be one of the measures we choose. So if that node has neighbors that are all significantly connected, say above this particular threshold, then that network is going to be displayed. So obviously this looks very, very dense and overwhelming because we've included every possible ROI. There's nearly 200 ROIs, and that in general is too much to really make sense of at this scale. So instead, what's usually a better approach is to select a network of ROIs. And they're grouped. I can't expand this, but they are grouped according to things like the salience network, dorsal tension network, frontal parietal, default mode network, for example. And what you'll notice if you try to, we only have 6 subjects, it's not very particularly strong. But if I hold down the left mouse button, select a subset of that, say default mode network, see how it prunes everything. Yeah. Oh, if you go to this drop-down menu and go to network of selected ROIs. So obviously, our correlation coefficient threshold is very, very low, right? So I could say, yeah, at a threshold of 0.05, there is in fact a significant network with this local efficiency measure as well. What would make most sense from my perspective is to use the z-score threshold, right? And in that case, it's really going to bottom out because we don't have a lot of power for this particular analysis. But in general, if you had this at, say, something like 1.96, which is a pretty typical threshold, notice that nothing survives correction at this particular level, right? But z-score for me is the one that makes most sense to use as a threshold before then using any of these analysis measures. I'm pretty indifferent to which analysis measure that you use. You would have to really be fluent with each of them to know the details between them. But in general, they're different measures of a network strength, right? There's some distinctions, but this is how I would threshold them in general. Okay? Yeah, Mike.
Sorry, can you import your own analysis? Does it have to be set up so that it'll play nicely with this, or how?
Yeah. Well, as I'll show you, if you have your own custom atlases, you really just need to define in M&I space, I should emphasize that, in a template space, which voxels contain what index. So if these voxels over here are 1, these are over here are 2, and I also assign them a label, then CONN will read them with no problem. Let me think here. I'm trying to remember who has what in terms of the hard drive that I gave people, but if I recall, what's that? I should probably take that back before I forget it. I'm assuming everybody up until this point is fine, right? Okay, we're good. I don't have that Alice in this particular case, but it's okay. We'll import it. Right. So moving on to custom Aliceses. Yeah. Oh, I almost forgot. Results Explorer for ROI to ROI. It's going to look a little bit different. than what we saw from Seed-to-Voxel. A similar thing with graph theory, but it is slightly different. We're not testing for individual networks per se, but we are looking at simply connections between different nodes. So let me see here. Go to advanced family-wise error settings. A more appropriate threshold in this case, I would say, would be something like 0.001 and a cluster level correction of 0.05. Has to thin it down considerably. This is going to be very hard to demonstrate here because the text is so small. But a lot of these different nodes tend to group either by network or regional proximity. And then the thickness of the band indicates the strength of the connectivity between them. This table will show you all the different clusters that are, in fact, determined to be significant. Again, F-test, you're going to see a lot of things, but won't necessarily be that informative. So this connectome ring, if we basically select everything that was there, this is based on all the different ROIs. So if you select a subset of ROIs, again, this is going to be a little bit more manageable. And you have to do that. They don't have a menu option through here, as far as I can tell. Oh, wait, actually we do. Yeah, so again, you could say select default mode network, for example. The reason you get all these significant connections when you have like everything select, oh, here we go. I was hoping that would bump up the text, but basically each one of these is a different node within that network. And you can also, from this table, see which of those nodes are significantly connected to each other. Display extended stats, and within each of these, say, different clusters, you can get t-statistics for one-to-one ROI connections. All right. Okay. I'm not going to go through comparing groups, but I'll just tell you right now, if you do compare groups with this particular data set, you're not going to get much of anything because there's simply no power to detect it. All right, so a couple more things. This was something that Mike just asked about. How do you use a manual, or sorry, a customized ROI, right? I'm going to show this in a viewer because it's a little bit easier to see this. Within this ROIs file or directory that I had people download, there are two files that need to be there. One is a nifty file that has voxels highlighted with different numbers indicating which belongs to a particular ROI. And there's also a text file showing which one, which of those nodes corresponds to what. Excuse me. So this ROIs.nii file, the index number 1 means it's the ventral medial prefrontal cortex. Number 2 means PCC, DACC, and SGACC. So I wrote that text file manually. This is just something I typed out, saved it in a simple text file. If I look at this in, say, fossilize, these are all in M&I space. So we'll add a standard template, which will be, let's pick this one. All right, so to see here, so number 3 is how I define this. I keep saying this. I don't have the time to go through like how I made this exactly, but I can send you instructions how to do it if you want to. So I labeled this as a 3. I labeled this as a 4. This as a 1. I think there's one more. Oh, yeah, a 2 over here, and these should correspond to those things I put over here. So number 2 is going to be the PCC. Number 1 is going to be VMPFC. I mean, these are very rough guesses on my part for where these things lie. But in the CONN Toolbox, I can load those in if I go to Setup and the ROIs tab. So if I click on this plus sign, I'm going to call this Andy ROIs. And it's going to ask you to select ROI definition files. So where was I? Yeah, this ROIs file. ROIs file. Simply click that one, and it will load. Now it's pretty sparse coverage, so I'll need to, click this up and down arrow to just see those dots, and just trust me, they're not overlaid on a template here, but they do match up in M&I space where they should be. Okay. Now, yeah.
Better practice to set up your own map like that, or would this be another place where you could pull in something like NeuroSynth?
Yeah, you could. Yeah, you could pull in something from NeuroSynth. You would need to use an image viewer to just manually label them as 1 or 2. So if you download a few different meta-analysis maps, for example, I think this is what Dozenbach did actually. You'd say find like the peak, or maybe define a cluster or a sphere around it, and then fill those in with 1s or 2s or 3s or whatever. Yeah. Okay, so at this point, unfortunately, because we're now defining a different set of ROIs, we would need to go through another set of denoising and analyses. First of all, analyses for all the subjects for that set of ROIs. Instead, just be aware that I'm going to load a different project that I've already made that will show how these ROIs have been loaded. So I'm going to open this. Go to give me 1 second. What's this? There we go. Some people may have this if they downloaded it off the hard drive, but it's arithmetic. Wait, is that right? Maybe I don't have this one actually. Scripted. I guess I don't have it. Anyway, I mean, there's no. Oh, here we are. Oh, yeah. Okay. Yeah. So this has had everything analyzed just with that set of ROIs for a single subject. So when I go to come on. First level analyses, and I go to this preview window here. You'll notice that, within the VMPFC, there's relatively high degree of correlation, and it's also correlating with that other part of the default mode network. Same thing for posterior cingulate cortex. It's highest in the PCC, and it also has significant correlation with the VMPFC up here. Okay, so I'm just demonstrating that this thing actually does work. I only used a single voxel. You can use more. You can place them wherever you want, but it reads it in pretty well, and then you just simply do the rest of your steps as you would. Okay, so I wanted to show that, and what was the last thing? Over here. Oh, setting up a PPI, yes. I'm just looking at the clock here, how much time we'll have. I'll tell you what, in the interest of time, I'm going to demonstrate this just on my computer for the PPI analysis. Is that kosher? Then I'll send out instructions later. I just want to make sure we have time for the last few things I wanted to do. Let me see here. Because you know, we'd have to download a couple things, more things manually. That takes time, and don't really want to do that. So I believe it was. I think it was this one. Yes. So the lucky ones who got everything from the hard drive might also have this as well. So let me back up and show you exactly what happened here. Within the Open Neuro data set, in addition to resting state scans, they also have some task-related scans. They have two conditions. They have a math condition and a control condition. I don't know the details. Maybe they just saw numbers or something. I don't know. Something like that. But in this, the Open Neuro data set, you know, within sub 1, there's the functional data. We have the arithmetic run 1, run 2. We also have corresponding events.tsv files, which I've also downloaded. And these are in a standard format. There are 3 columns. There's onset, duration, and trial type. So if you don't already write out your timing files like this, I highly recommend it because it's so easy to use them with the CONN Toolbox. The onset is the onset time in seconds from the beginning of the run. Duration is the duration of that condition in seconds, and then there's a label for control or main condition. So all I've done, I've just downloaded this into the same, you know, directory as the rest of my data. It's got to power through. You know, this just for a single subject, load the structural as we did before. For the functional data, I load 2 separate sessions because now you know, we can extend this to multiple sessions if we want. So there's 2 sessions of functional data, and in each one they're doing a math task and a control task. When we take our next break, thank you. Yes, it was cough drops. Which, yeah, I do need those. Okay. Right, and then the main thing here is looking at the conditions. Now, how did I get all of this? What you could do is you could, you know, click on the add button. We're familiar with this basic format. You enter a name, and then you would manually enter the onsets and the duration for each onset. I don't want us to go through that exercise. It's tedious. You know, maybe you do it once, but you never have to do it again. Instead, since everything is in this BIDS format, if you have the timing files, all you need to do is click on Condition Tools and then import condition info from text files. It's going to ask you, are they BIDS compatible files? And is there one of those onset files for each subject and session folder? If your data is organized in BIDS format, it identifies them, where they're located for that particular subject you selected. In other words, if I selected all 6 subjects, had 2 conditions, 2 runs per subject, and I had their timing files all in their func directories, they would automatically assign all of them instantly. So, you know, I click on that. You can just select a representative file, and it selects all of the conditions, no problem. What I have highlighted in orange here, when I select control condition, that's the control task, and main is the main task. So think of time as going from left to right here. Yeah? And it's also separated into 2 blocks. This is the first block, and this is the second block. Run or session, you know. So the control condition for session 2 is highlighted here. Main condition for session 2 is highlighted there. So it should look something like this when you import it. Now, okay, so we would run through all the pre-processing, all the denoising, all the filtering, all that stuff. When you get to analyses first level, the one change you'd want to make, the default is functional connectivity. You'd want to change this to GPPI, task modulated effects. When you select that, it gives you the option of which task conditions of interest you want to do. 1 second. And in this case, you can simply select 2 of them, or if you want to do a GPPI, you can select all of them. That's what I recommend that you do. It's the most statistically appropriate way to do that. In this case, I don't see any significant effects at a pretty low threshold. Lower it, I'll see it. What does this mean? This isn't a study designed for GPPI, so I can't say. But this is how you set it up. This is the template you can use. All right, so we covered, comparing group. Oh, yeah. Multiple runs, multiple time points. When you say multiple time point, like pre-post or something like that? Oh. Is that specifically what you're asking about? Okay, yeah. Yeah, that was, I should cover that actually. In that case, I'm going to use the same data set as an example of that. It's, let me see here. Let me make sure I'm doing this correctly. It is in covariate's second level, and add a new one here. Wait, let me see here. I guess I'll have to check this thing out to see how to do it. Setting up a pre-post design, okay. So yeah, if we just have 2 sessions, we're going to, even though these are collected for the same subject, let's pretend that they were collected at different days or something like that. Okay, we've already done that. Conditions, that's right. Yeah. Come on. Delete this. I was trying to BS my way through it. Didn't want to admit I didn't actually know how to do it, but I did write it down, so that's a good thing. So let me see here. Yeah. So in this case, let's pretend that these were 2 resting state blocks, right? So I'm going to delete both of these. I'm going to create one that's called pre, let's say. Condition spans the entire session. And for post, I need to select session 2 to create a new regressor for that. Post. And then spans the entire session. Let's see here. I'm not sure if I can show this in... Do I need to reanalyze everything? Shoot. Sorry, I need to go through everything in order to show you how to set that up. But that's how you set up the regressors, and once you have them, you should be able to select them as you would, like those effects we had for group A, group B, and so on. Let me just make sure I'm setting that up correctly. Is that right? Yeah, I think that's all you need, and then later on. I am still working on this module, and I'm trying to cover as many different scenarios as possible. So once it's finished, and I have like a suitable group level analysis, that'll be most informative, yeah. But yeah, this is how you set it up at the individual subject level. What else do we have here? Okay, last thing before we talk about analyzing a new data set. Give me 5 minutes. I need those things. So let's break briefly. Okay, we're going to make it. Don't worry.